So in this lesson we're going to talk about dimensional analysis, which is the process that we are going to be using for the majority of the mathematics that we do in chemistry. So let's do a quick just little refresher about how do we multiply fractions, because we're going to be converting from one unit to another. You need to be able to convert in fractions. So maybe you learned this trick when you were in math class long ago, that if you had, that's supposed to be a 2, if you had 2/3 and you multiplied it by 1/2, if I've got a 2 in the numerator and a 2 in the denominator, they can cross cancel. So 2/3 times 1/2 is 1/3. If I take a fraction and I multiply it by a whole number, let's say I do 2/3 times 3, I can think of that whole number as a fraction also just by putting it over 1. 3 is the same as 3 over 1. Now when I go to multiply these two together, I have a 3 in the numerator, a 3 in the denominator, they cross cancel. So 2/3 times 3 over 1 is 2 over 1, which is the same as 2. That is the kind of little cheat sheet or shortcut that we're going to be using for dimensional analysis. But with dimensional analysis, it focuses on units, not so much the numbers. The numbers are important, you still need them, but we're really going to do a little analyzing of the units. So with dimensional analysis, you start with the unit that you have and the unit that you want to convert it into. In other words, figure out your givens and your unknowns. What do you have? What do you want? Then you're going to write a relationship for those two units. In other words, a conversion factor. Maybe it's something you have to look up. Maybe we give it to you. But what is the relationship between your known unit and your unknown unit? 12 inches and 1 foot. 1 pound is the same as 0.54 kilograms. How many feet in a mile? All those types of things. Once you figured out your relationship, you can write it as two different fractions. So 1 foot over 12 inches or 12 inches over 1 foot. It's the same relationship. The relationship you choose depends on what your problem is. So choose the fraction that's going to cross cancel the original unit, leaving you with the new unit. So you get rid of what you have and you're left with your unknown unit, the one that you want. Now about these units, some things you're going to have to know just kind of off the top of your head. So you've seen these before in other science classes. The ones that we are going to use the most in chemistry are these three. So make sure that you have these committed to memory. Push pause, write these three down. There's 1,000 grams in a kilogram. That's the biggest. So there's a kilo means 1,000. There's 100 centigrams in 1 gram. Centi is smaller. There's 100 cents in a dollar, so it's a smaller piece. Milli, like there's 1,000 milliliters in 1 liter. We use these three quite a bit, so you'll have to know those off the top of your head. Other units we're going to give to you. Let's do some examples, probably the best way to see how dimensional analysis works. How many grams are in 1,500 grams? So let's identify what we have. How many grams, there's my unknown, are in 1,500 grams? There's my known. The unit that I have is kilograms. The unit that I don't have is grams. Let's look at the relationship. What do I know about grams to kilograms? Well, I know that there's 1,000 grams in 1 kilogram. So now I'm going to write my relationship as a fraction. First I start with my given. What do I have? I have 1,000 kilograms. And now I'm going to write my relationship as a fraction such that the unit that I want to get rid of is on the bottom so that it can cross cancel. The unit that I want is on the top. So just like with the fractions that we were showing you earlier, look at your units now. Kilograms cancels, kilograms cancels. It leaves you with grams. Lots and lots of zeros. Okay? So there's how many kilograms, or how many grams are in 1,500 kilograms. If it helps you, you can think of this as a fraction as well, put it over 1, but it's the same thing. How many liters are in 4,350 milliliters? Here's my unknown unit, here's my known unit. So now I want to think of the relationships between liters and milliliters. In 1 liter, there are 1,000 milliliters. Okay, these two examples are part of the units that you guys just kind of need to know. Start with your given. How many milliliters? We've already identified the relationship. That's here. How many liters and milliliters? I'm going to write this relationship in a way that my unit that I have cancels out. I don't want milliliters, so that one has to go on the bottom. I want liters. That has to go on the top. So in 4,350 milliliters, there are 4.35 liters. Now with both of these, let's take a minute and make sure that we've got the right number of sig figs. I'll do this in a different color just so you can kind of see it. My given is what you're going to use for sig figs. There are 2 sig figs in my given, so I need to have 2 sig figs in my answer. So those match. In this one, I've got 4, just kidding, 3 sig figs in my given. So I've got 3 sig figs in my answer. So those match. Couple more examples. Let's use one with a miles per, so you know how to deal with those. If you're driving at 75 miles per hour, mph, how many miles have you gone after 2 hours? So how do we treat this mph? So keep in mind that that is your relationship. Miles per hour means that for every 1 hour you drive, you'll go 75 miles. So how many miles have you gone after 2 hours? So if you've been driving for 2 hours, and each 1 hour gives you 75 miles, notice how your hours unit is canceling out. So now you got 2 times 75, 150 miles. Sig figs, 2 sig figs in my answer. Alright, my golden retriever puppy, Jake, he's kind of a beast. He weighs 50 kilograms. How many pounds is this? This might not be a relationship you know of off the top of your head, but I gave it to you in the introduction. Every 1 pound is 0.454 kilograms. That's my relationship. Start with my given, 50 kilograms. And now let's set up my relationship in a way that the unit that I have, my given, will cross cancel. And the unit that I want is left on top. So 50, and again you can think of this as being over 1 if that helps you. 50 times 1 divided by 1 times 0.454. So when I do this math, this comes up to be 110 pounds. Check your sig figs. 50.0, that's 2 significant figures. 110, that's 2 significant figures. I'm good. Alright, let's try a slightly more complicated one with multiple steps. How many ounces are in 2.27 kilograms of potassium? Here's my unknown unit, ounces. Here's my known unit, 2.27 kilograms. Now with something like this, if you don't know a relationship just off the top of your head, you might just kind of have to do a little listing of what you know and what you don't know. So as I was saying before, I know that I've got 2.27 kilograms. I'm trying to get to ounces. That's my unknown unit. Since I can't get there in one step, I don't know of the relationship right off the top of my head between those two, I'm going to use little baby steps that I do know. Then for every 1 pound, there are 0.54 kilograms. I use that in my doggy problem. I also know, just from the grocery store, that every 1 pound has 16 ounces in it. So now I've got 2 different relationships that I can use to solve my problem. So let's set this up. 2.27 kilograms is what I have. I'm going to use my first relationship that eliminates the kilogram unit and leaves me with pounds. So every 1 pound is 4.54 kilograms. Now if I analyze my units a little bit, kilograms is going away, leaving me with pounds so far. But I'm not done because I want ounces, not pounds. So now I'm going to use my next relationship. Every 1 pound has 16 ounces. So look at your units. Pounds cancels out and leaves me with ounces. So 2.27 kilograms is the same as 80 ounces. Now if I put that in my calculator, that's what's going to give me 80 ounces. Check my sig figs. I got 3 sig figs here. I only have 1 sig fig here. So how do I turn that into 3 sig figs? Don't forget your rules about decimal places. You can add a 0. Now I've got 3 sig figs. Yay! And that's how you do dimensional analysis. Now about these units Where do we come up with all these lovely units? Well, a little story for you about units first, involving the Mars Climate Orbiter. So once upon a time, they were developing an orbiter to go around Mars and take samples about its climate and send information back. And so it originally took off. There's lots of different labs involved there, some pretty pictures, Jet Propulsion Lab, NASA, Lockheed Martin, some local companies that we know of. 1998, set off on a rocket. However, so this is sort of the artist rendition of what was supposed to happen. Turns out it actually then crashed a year later into Mars. Reason being is there was a mix-up between the units. One team, one science group used one unit, another team used another different unit. And so that was a really expensive math error. So that's why we need to use dimensional analysis. Which brings me to my final point about units, and that would be what units do we typically use, and those would be the International System of Units, the SI units. You need to know these things, so press pause and copy them all down. What I would definitely know is make sure that you know what the quantity is that's being measured. What is the name of it? So a mole is the amount of the substance, meter is length, kilogram mass, time is in seconds, temperature is Kelvin, amperes is current, and candela luminous intensity. We don't use all these in chemistry. Physics uses quite a few. Know the abbreviation as well, but these are the base units, the units that every scientist all over the world understands. And so these were developed to kind of solve some of those problems like the Mars Climate Orbiter. What happens when you have people in two different countries working on the same problem? You have to be on the same page. And so the dimensional analysis is the tool that we use to help us convert from one unit to another. Hope that helps. Have a great day.